Okay, next thing is resizing arrays in VB. In VB, we may freely resize an array using the redim keyword, where you specify an integer n and the desired new size of the array. Note here redim is short for redimension. For instance, redim friends 5. This statement resizes our array friends to size 6 elements. Side effect, unfortunately redim also clears the array by default. Actually redim destroys the old array and gives us a new one with the same size but empty. To prevent this, you must use the preserve keyword with redim. For instance, redim preserve friends 5. This again creates a new 6-element array, previously of size 5, but now also copies the stored information so you don't lose it. Note that array resizing is a VB extra, which by that he means it's not supported in C# and other Microsoft-based languages. So here's an example of resizing an array, so let's see it in action. Change our code to resize friends and add one friend. So here we have the original, then we resize it like this. So this had 5 elements, this is now going to have 6 elements. And then we can add to the last element, we can give it a value of Totoro. And then size of friends and get the length. And sort and display friends. And so it's a length 6, and now we have this. Multi-dimensional arrays. So multi-dimensional array means like this. So this would be a well, that's not, wait, let's see, doesn't have an example, good picture of it. But so you'd have like an element here, 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 here, all these different elements. So we would say that the first we'd say this is a 2-dimensional array. It has columns and rows, that's 2 dimensions. And we'd say there are, the first dimension is the columns. Wait, let me just make sure of that. Let's see. This one is 1, 2, so it's the first dimension is the row, and the second dimension is the column. So this says, I guess I could have seen this before, but this says that the dimension, the size of the first dimension is 4. Remember, this is 3 plus 1, and the size of the second dimension is 5, 4 plus 1, right? So which one has size 4? The rows, and which has size 5? The columns. There are 5 columns, there are 4 rows. So I made a mistake. So this refers to the column size, well, size minus 1, and this refers to, did I say that wrong? I'm sorry. This refers to the first dimension's size minus 1, in other words, the rows, and this refers to the second dimension's size minus 1, in other words, the columns. Okay? I don't know if I just made that very complicated, doesn't it? It's not as complicated, maybe I just made it with all my mistakes. But anyway, shown below is a 4 by 5 array of integers. So there are 20 elements here because it's 4 by 5. This is a 2-dimensional array, and it's declared with this statement. Okay, so here's how we declare this 2-dimensional array. Remember how we declared the 1-dimensional array? Was back here. So dim friends 3 as string. Now if it was a 2-dimensional, we'd say friends 3 comma 4, for example, as string. So we have an extra argument in friends here. I guess I can call it an extra argument. Okay, so there it is. Now, so here, 1 comma 2, where is this element? What row is this in? What column is it in? So it's in the second row, and it's in the third column, right? 1, 2, 3, third column. So, but remember the indexing, we have to do 1 minus. So instead of saying it's in the second, we say it's 1 minus a second, second minus 1, so it's 1. Instead of saying it's in the third, we say 3 minus 1, so it's 2. So this is the 0, 0 element, this is the 0, 1, 0, 2, 0, 3, 0, 4 element, and then this is the 1, 0, because this was the 0th row, this was the first row, the second row, the third row. So the 1, 0, 1, 1, 1, 2, this is the 2, 1, 3, like this, okay? So, example shown below is a 4 by 5 array of integers, 20 elements. This is called a two-dimensional array, and it's declared like this. We're using integers, so it's declared like this. Okay? I mean, it's going to take integers in here. So, it's declared like this as integer. Below is another simple example of a two-dimensional array. Again, the declaration creation is similar to that used to make one-dimensional arrays. Note that the vertical dimension, the rows, is indexed first. So if I had read that, I would have remembered that, but okay. All right, let's read this. Our examples today have used one-dimensional arrays. However, VB.NET also supports multi-dimensional arrays. Note, for space, I abbreviate multi-dimensional as MDM. That's just his abbreviation. It's not a standard abbreviation. I've never seen that before, but he just doesn't want to write out multi-dimensional. MDM arrays are useful when modeling real-world objects and situations with more than one discrete dimension. Discrete means, I don't know what he means by discrete dimension. I don't know what a non-discrete dimension would be, but maybe there's such a thing. I don't know what that would mean, though. I would usually, I would never think of like a 3.5 by 4 dimensions matrix, but maybe there's such a thing, I don't know. For example, a classroom with 20 rows and 15 columns. This has 2 dimensions, length and row. Instead of modeling the dimensions separately, we model them together as a two-dimensional array, two-dimensional, multi-dimensional array. A VB MDM array can also be declared or created in one step, so we can do it in one step as well as 2 steps. Oh, sorry, it can be, yeah. Simply specify the additional dimensions as shown by the two-dimensional array below. You may specify up to 32 dimensions. Wow. So this is just 2 dimensions, but you can have up to 32 dimensions in here. But once you declare it, you can't change the number of dimensions. It's fixed. Example, for a classroom with 20 rows and 15 columns, you might say the seats in class are 19 and 14, right? Because 15 minus 1 is 14, 20 minus 1 is 19. Right? So, because we also have 0 and 0, so that actually gives us 20 rows and 15 columns. Note 1, in VB, the upper bound is used for each dimension. And all of the dimensions must have the same type. So they all have to be the same type. They all have to be integers, for example, in this case. So here we're declaring my array to be of 4 rows and 5 columns. 3, 4 means 3 plus 1 is 4, 4 plus 1 is 5. The code to access each element is shown in the corresponding cell. So if I want to access this element, I would do 0, 0 element. If I want to access this one, it's the 0, 1 element. So you always mention the row first and then the column. Row first and then column. I'll say it again. Row first and then column. I'll say it again. Row first, then column. Keep in mind that each dimension of all arrays are 0 indexed. So they're always 0 indexed. Okay, working with array dimensions. So we have some, we can do rank, which tells us how many dimensions there are. Okay, we can also do something called get upper bound, and so on. We'll look at that in the next video.